Hi, my name is Scott. I'm a coral reef scientist with the National Oceanic and Atmospheric Administration, or NOAA. Please join me in exploring the world of coral reefs from outer space to below the ocean surface. If you close your eyes and picture a coral reef, you might think of a beautiful landscape of colours and shapes swaying under the ocean waves. Coral reefs are filled with biological diversity, and people around the world depend on coral reefs for such things as fishing, protection from hurricanes, new disease-fighting drugs, and great places for recreation. On top of all this, they are important for the proper functioning of our planet. Though some coral reefs reside in deep, cold waters, most are found in the warm waters between 30 degrees north and 30 degrees south latitude, and at depths less than 60 feet. On this map are plotted the locations where major coral reefs occur. You might be surprised to know that some coral reefs can actually be seen from outer space. But if we dive down under the surface of the ocean and look closely at a coral reef, we notice that the reef is made up of many different species of algae, sponges, fishes, invertebrates, and most importantly, the coral animals that build the reefs. Thousands of coral animals, called polyps, may be found in a coral colony. These coral polyps live in a special cooperative relationship with microscopic algae called zooxanthellae. The zooxanthellae actually live inside the coral's tissue, providing the coral with food, oxygen, and other nutrients that make it easier to survive, while getting the benefit of a home. They also give the corals most of their vibrant colours. Corals are animals, and just like us, they are sensitive to extremes in hot and cold temperature. Just like our bodies get stressed from really hot weather, corals also get stressed when the ocean heats up. When people get hot, they turn on the air conditioner. But one way corals deal with this heat stress is by expelling their zooxanthellae partners. This process is called bleaching, because without the colourful zooxanthellae, the coral turns a pale white colour. Bleaching is very bad for coral reef communities because it can create a snowball effect with negative impacts on all of the plants and animals that live on the reef. Without living corals, algae can grow in their place, and ultimately the reef habitat and the resident animals will disappear. The reef goes from healthy and beautiful to sick and empty. Scientists are trying to figure out exactly why corals bleach and what can be done to stop it. However, there are just too many reefs for scientists to directly observe all of them. That's why NOAA also monitors coral bleaching using its satellites that are 800 kilometres or 500 miles above Earth. These satellites orbit around Earth from pole to pole about every 100 minutes, taking many types of measurements that are used by scientists to study the complex environments of our planet. One kind of data that NOAA collects from its polar orbiting satellites is the temperature of the ocean's surface. Sea surface temperatures allow scientists to see how warm the oceans are all around the world every day. This animation shows how the water temperature changes over the course of a year. Notice the seasons. The ocean gets warmer in the northern hemisphere around May as northern summer begins. The southern hemisphere is cooler during that same time because it is winter below the equator. Then notice how the pattern switches as the year ends, with the north growing cooler and the south growing warmer. Our research group at NOAA uses ocean temperature data to look for places around the world where coral reefs might be at risk for bleaching. When the water is warmer than the highest temperature you expect to see in the summertime, coral reefs start to get stressed. In this animation, ocean areas that are coloured are above the average temperature that corals usually experience in the summer, and corals there are under stress. Yellow, orange, and red indicate high stress levels. You can see a period of stressful temperatures in the southern hemisphere, around Australia and in the Indian Ocean. Then, a large pool of hot water builds up around the entire Caribbean Sea and Gulf of Mexico. The biggest temperature problems for coral reefs happen when the oceans get hot and stay hot. This data animation shows how heat stress builds up over time. Areas where the colours are yellow to red are at high risk for coral bleaching when corals expel the zooxanthellae that live in their tissue. Near the end of this animation, from 2005, you will see that the corals in the Caribbean and Gulf of Mexico region were highly stressed by hot ocean temperatures that lasted for weeks and in some places even months. Coral reefs throughout this region bleached. By the end of the year, the stressful conditions were over, but the damage was already done. Half of the corals died in some areas of the Caribbean, and the heating stress is only expected to get worse. As you can see on these graphs from 3 coral reefs around the world, the projected trend is that the oceans will continue to warm, perhaps 3 degrees Celsius or 5 degrees Fahrenheit warmer in the year 2100 than they were in 1850. Notice that these temperatures are well above the red line. That is the current level that corals in each area can tolerate. But you know, temperature isn't the only thing that stresses corals and can threaten the health of a coral reef. Pollution, overfishing, disease, and hurricanes are just some of the threats. The challenge to corals posed by the climate change crisis is an issue that the global community is trying to address. In the meantime, many nations around the world, including the United States, are trying to minimize the other local stresses by establishing marine protected areas off limits to certain activities such as fishing, polluting, and boating. On a local level, these marine protected areas work well to save the corals living inside them and provide a refuge for fish and other animals to safely grow. But they cover only a small fraction of the world's coral reefs. We need to do much more to protect corals. So what can you do? A lot! Whether you live 1 mile or 1,000 miles from a coral reef, your actions affect the future of coral reefs. Everything flows into the ocean. So reduce your use of fertilizers and pesticides and use phosphate-free detergents. For more information about what you can do, visit www.coralreef.noaa.gov. That's all for now. Thanks for taking the time to hear about coral reefs.
想知道更多讯息吗？请上网站 sos.noaa.gov